Hi, everyone. Good afternoon. Thanks for joining us today. It's a great pleasure to have you all here. Hope you're having a great time at reInvent. My name is Balaji Iyer with AWS Professional Services. I'm here today with my colleague.
Hey, good afternoon, everyone. My name is Prahlad Rao. I'm an AWS Solutions Architect.
Today's session is optimizing the data tier in serverless web application. This being a 300-level session, we assume you have a foundational understanding of Lambda. As we all know, every web application needs a data tier. It's very important to choose the right data tier based on your workload pattern. Whether it's NoSQL or SQL, do you want to add a caching layer in front of your database? You're also trying to answer some very important questions. How can I scale my data tier? How can I reduce the lag time? How can I reduce the latency and increase the performance of my application? The goal of this session is to help you with that information, specifically around choosing the appropriate data tier for your serverless web application. We will also look into some VPC configurations, some best practices, performance guidelines, and some design considerations around language runtimes, retries, and caching. Let's get started. We're going to start with anatomy of a typical serverless application. We will look into two different architecture patterns, web application and a mobile application. Then we will look into how Lambda integrates with each of the data tiers, DynamoDB, RDS, and ElastiCache. We have excellent demos for each one of them. So we will also look into some additional best practices, and we'll have some time for Q&A. Here's a construct of a typical web application architecture. So in this example, I have a simple blog site. As you can see, Amazon API Gateway is your front end. That's where the users are going to be connecting. There will be users connecting to your website to view the blogs. And there will be users trying to get access to your blog site. They're creating a new account. They get authorization. So in this case, I'm using a Cognito as an example for managing users. Cognito User Pools is a new functionality that we released. We have some demos that can go into detail of what it offers. And once the users connect to API Gateway, and Lambda is your logic tier in this case, where the users can trigger for signups, and they get a SES email with a verification ID, and they can use that for login to your website. That's all provided by Cognito. And your Lambda function will trigger that email. Once you get your authorization email, you will connect to your logs website. And at that point, your AWS Lambda can help you connect to each one of the data tiers. Another architecture pattern is using a mobile. Let's say you have users that are connecting to your mobile application. Same pattern, Amazon API Gateway is your front end. And your logic tier is provided by the Lambda functions. And your data tier, you have different options to connect to. If you noticed, we're not using any servers in both of these architecture patterns. We're using Lambda primarily. It's a serverless way of executing code. If you listen to Werner's keynote this morning, he mentioned we moved from pet to cattle to now onto herd. And this is your herd. You don't have to manage any servers or the networking components. You're just using compute as a service provided by Lambda in a purely serverless manner. In the world of serverless, the hardware becomes invisible. And you're primarily connecting to Lambda for executing various components of your code. I want to introduce you to different data tier options that we have in AWS today. The first one is Amazon DynamoDB. It's a document and key value store, very highly scalable, and it's a NoSQL data store. And there's Amazon ElastiCache. It's an in-memory key value store. It provides fully managed and highly scalable Redis or Memcached. And there's Amazon RDS. It is a highly scalable, fully managed relational database. Supports a variety of database engines. Then there's Amazon Redshift. It's our data warehousing solution, primarily for your analytics-based workloads. In this specific talk, we're going to cover DynamoDB, ElastiCache, and RDS. There's one decision that you got to make early on. NoSQL or SQL. So how do you choose that? What are some of the things that you look for to making that decision? It depends on the data you're trying to use. Is your data that's heavily structured? Does it have a partial schema? Is it denormalized? Is your data a simple key value pair store? For example, you're processing a big data stream. You're processing a log stream. You're managing some key value pairs. We will see examples for some of these. The performance and availability at scale is really the key when it comes to NoSQL stores. By using NoSQL, it provides horizontal scaling options. On the other hand, there's SQL. Is your data supports a strict schema? Does it require a strict schema? Does it involve complex relationships between data sets across tables? Is your data transactional in nature? Does it require the ACID principles, atomicity, consistency, isolation, and durability? Then SQL is your option. What if your data is ready to support NoSQL, but you have a lot of tool sets that are built around SQL, and you have a lot of dependent applications that already understand SQL? So how do you choose which one to use at that point? You have to weigh in the choices depending on what you're trying to accomplish in your application. Here are some of the common use cases that we see using DynamoDB. Ad tech is very popular using DynamoDB due to performance and scale and millisecond, microsecond latency you can accomplish using DynamoDB. Let's say you're trying to place an ad and you have only a few seconds, milliseconds to be able to show which ad you want to display. Or user session management. That's another very common use case. IoT is a very popular use case as well, where you're getting a lot of metadata from millions of devices and want to provide real-time notifications. Gaming. Are you trying to handle a leaderboard that is constantly changing? Mobile and web, very popular. Are you trying to store user profiles for your users that are connecting to your website, and you're trying to cache session details? Are you trying to store specific metadata for your user or your application? We see DynamoDB a very common use case for a lot of these patterns. So what does the configuration look like for Lambda with DynamoDB? Since it's serverless application, there's no VPC configuration required. You have IAM roles for user authentication. Unlike a traditional SQL Server database, you have to have a user ID and a password to connect to it. In this case, it supports IAM firsthand. So you can leverage the fine-grained access control. What it really means is you can have user access specific to certain rows of your DynamoDB or certain columns of your DynamoDB. You can accomplish by using this fine-grained access control that is provided by DynamoDB. DynamoDB API offers a very simple user model. There are about 15 different API options that is available for DynamoDB: create table, delete table, scan, and so forth. And you can invoke concurrent connection scale. In our example, we're going to see like how DynamoDB can scale to be able to handle traffic by offering a simple configuration setting. If your performance needs to be increased, you can simply dial up your read and write speed, and you automatically get that new performance that your application needs. DynamoDB is a persistent data store. So your data is stored in the disk. So it can provide you a single-digit millisecond latency. What if your application needs microsecond latency? What do? You can front ElastiCache in front of your DynamoDB, and that can offer you microsecond latency for your application, especially for read performance. First demo, I'm going to show a blog application where users will be connecting to API Gateway. It offers fully managed CRUD functionalities. We will see different HTTP methods for each of the use cases. And that will trigger a Lambda function when I first sign up. And once I signed up, I'm going to use that user ID and password to create new blogs and manage my blogs. So what I have here, it is a simple blog application. So it's a sign-up page where I'm pulling in my information. And once I click submit, and I get a verification code through my email that I have configured using Cognito User Pool. Cognito User Pool is a fully managed user management solution that is available in AWS, where I have lots of different users here. You could set different attributes of some of the questions that you want to request as they sign up. You can set password policies, the minimum length for the password, and other settings. Do you want to turn on MFA for your users? And you have different message customizations for different code paths. You can remember user devices on how they connected to. You have like different triggers that can trigger a specific Lambda function depending on what you're trying to do for each of the code paths. So I already have a user ID that is created. So I'm going to refresh. And I have published a few blog posts, as you can see. On the back end, it uses DynamoDB. You could see the first blog, second blog, third, and welcome, and so forth in your DynamoDB table. Let's take a look at one of them. I'm going to log in, and I can see all my blog posts. Let's say I want to update a blog post. I want to remove this and publish it. Then I can go back to my blog site. I can see the newly updated already there. So what happens in the back end? So what you're connecting to is the API Gateway. So API Gateway offers all the HTTP functions that you want to automatically configure. So the clients is your customers connecting to that website. And that invokes a method request. that's going to call the DynamoDB table. So in this case, I have configured the method request to perform certain actions. So these are the different options that is available for you for configure specific user requests. When you go to integration path, you notice I am executing a call to my DynamoDB database. So this is how I'm updating to my DynamoDB database on the back end. And I also have a simple JSON blob for my front end. If my front end application wanted to get the JSON and want to do some interesting things with that, they can access this URL, and I can render that information. So let's post a new blog. Then I refresh my page. Sure enough, the new blog post appears. And there's the entry in your DynamoDB table that is automatically added, which we could see from here, right? So what we saw here, your front end is provided by API Gateway. You don't have to create those invocation methods. That's automatically configured, and you just got to set in the parameters. And inside your message, where you're invoking the post method, I'm adding an entry to my DynamoDB table. And in my front end, I'm simply querying that request and providing that information. Now I'm going to hand over to my colleague, Prahlad.
Good afternoon. So as we just saw, Balaji took us through the configuration of enabling Lambda functions to talk to backend data tiers like Lambda. What I'm going to take us through the next few minutes is Lambda connecting to the backend SQL database, like any relational databases, Aurora, MySQL, Oracle databases that you want to choose, and also an ElastiCache layer that you want to front end in front of your database as well. So we'll walk through both the configuration and a demo of how Lambda can interact with both these backend data tiers and look at some of the considerations around configuration and performance. So I think people who are coming in from the SQL world, they pretty much realize that where you'd be using relational databases for mostly strict structured data sets, transactional queries, and things like that. So RDS provides a managed, fully managed relational database experience that offers the favorite database that you can set up and provision within a matter of minutes, like Oracle, Microsoft SQL Server from the commercial side, and various open source databases like MySQL, Postgres, Aurora, and a few others. So typical use cases, wherever you require a relational database with a Lambda function that's front-ending it, you would want to use an RDS. And the good thing here is RDS gels very well with the serverless nature of Lambda because, again, here you are not necessarily managing the underlying hardware, the operating system, and server for your RDS database because it's a managed database experience that you can simply click and launch a database in a few minutes and access the database using SQL endpoints. That's all you need to do, right? All the other complications of the underlying operating system, database configuration, backups will be done by the RDS service. In addition, if you want to easily move or migrate data from your on-premises databases to RDS, we also have database migration service tool that you can take advantage to either replicate data for backup or DR, or simply use that to migrate your databases to AWS. Amazon Aurora is a fast, highly available, and fully MySQL-compatible database. So when we say MySQL-compatible database, this is not just a fork of MySQL. Aurora has been written from the ground up to be able to support the necessary performance and high availability. So in order to, how did we achieve that is we have separated out, or we have decoupled the SQL and the transaction layer away from the underlying data layer. That means you can scale your SQL layer, which sits on an RDS EC2 instance, whereas the underlying data tier is a high-performance data storage that's shared by the Aurora database. So by doing this, we are not only decoupling the SQL versus the backend tier, but you'll also have the ability to replicate and also take advantage of the high availability nature of the service. As you can see, any data that is written to Aurora database is replicated across multiple availability zones in a region. In addition, it can scale to as much as 64 terabyte with up to 15 RAID replicas. This is super helpful if you have a very read-heavy workload and you want to distribute read traffic across multiple replicas. And what you can do when you couple with Lambda functions, you can easily parallelize multiple Lambda functions and then try to query the read replicas at the same time. So as Balaji walked through the configuration and performance, I'll be doing the same with RDS and ElastiCache. So there are two aspects with RDS when you want to invoke or when you want to interact a Lambda function to a RDS database. Number one is, since an RDS database lives within a VPC that you own and manage, Lambda would need to be able to access the VPC resources in order to be able to interact with an RDS database. Lambda functions, when you create, will have default access to internet. That means you can easily call using public endpoint and whatnot. However, if you want to grant Lambda function access to your VPC resources, for example, RDS, ElastiCache, and your own EC2 instance that you might have an application associated with, then you need to make some configuration for your Lambda function. It will not have the default function that allow you to easily connect to a VPC resource. So number one, you need to make sure that you allow the appropriate subnet and the security group configuration within the Lambda. I'll show you that in a minute on my demo, where you can easily specify what subnet your Lambda function should be able to talk to with your VPC resources and the security group rule that the Lambda should be able to interact with your resources. In addition to that, Lambda would also need to have an IAM function execution role. Because it will not have default access to the resources, you would need to explicitly assign an execution role to the Lambda function so that Lambda, when it needs to talk to a VPC, when it needs to talk to an RDS resource, it will simply provision an elastic network interface at the back end, and that's done by the service. And then that ENI would be attached to the VPC resources. Thereby, the Lambda function will have a path or a routing path to access your RDS resources. And of course, the security group rules, let's say, for example, your RDS database should allow inbound rules to allow traffic coming in from the Lambda. By doing this, when you enable access for your Lambda to VPC, it will also gain access to other peered VPCs that you already have in place, including VPN endpoints and your private S3 endpoints. That means it can easily take advantage of the private S3 endpoints to be able to talk to S3 as well. However, keep in mind that, as I mentioned, by default it will have access to internet. However, when you enable a Lambda function, access to VPC resources, it loses access to internet. So that's by intentional, because we want to ensure that there is separation. So what you want to do, even if you have your configuration set within your VPC, say auto-assign public IP within your subnet, and you have an internet gateway that is attached to your VPC, and all the necessary configuration that is done, you'll still not be able to have a Lambda access a VPC resource and a public endpoint at the same time. So what you do, for example, you might have a situation that a Lambda function would need to have access to an RDS. At the same time, it needs to maybe talk to DynamoDB, which is a public endpoint, or a KMS service which Lambda can use to encrypt and decrypt database credentials that you use for your RDS database. What do you do with that? So you can easily either provision a NAT instance within your VPC and then have the Lambda function associate that with the NAT gateway so that it can route traffic from the Lambda function to the internet or to the public AWS endpoints through the NAT gateway. You can also easily take advantage of our Amazon VPC NAT gateway. Very simple. You can get up and running with a NAT gateway in a couple of minutes with a couple of clicks. I have the demo as well. So by doing that, you're also ensuring that you have the right security control in place. That means the Lambda function will only have outbound access to the internet or to the public endpoint without exposing everything through the NAT gateway. At the same time, the Lambda function can securely access your VPC resources like your database, EC2 instances. Keep in mind that you need to have enough IPs for your ENIs. That means for every Lambda invocation, it will create the necessary elastic network interface at the back end. So that means, let's say you invoke a Lambda function now, you can actually go to the console and you can actually, within your account, you'll see an ENI that was created. And after some time, due to the nature of Lambda, right, the ENI will simply go away. It's cleaned up at the back end because the Lambda will go into a cold state. And the next time you again re-invoke, again an ENI is created. So make sure that you don't need like unique IP address or ENIs, but just make sure that you have good number of IPs to support Lambda accessing your VPC resources. Also, if you have any EC2 instances or your applications within your VPC that has a public facing or that talks to the internet, try to avoid DNS resolution of the public host name when you are accessing the Lambda function, because it adds the additional latency for it to get the name resolution and then go and talk to the necessary resource. So let's say you have your RDS database. When you launch an RDS database within a VPC resource, unless you require, just don't enable public access to the database. That means it will have private IP, so that when Lambda, it will only talk through the private IP layer, where thereby it does not have to go through a DNS resolution process, which will add more latency and cost to your Lambda function. From a performance perspective, it is very important to choose the appropriate RDS instance for high concurrency. Unlike DynamoDB or ElastiCache, which is designed to handle for scale, RDS at the back end, it's still a relational database, right? So you need to make sure that the database can support the appropriate number of concurrent connections that you want to issue from your Lambda function. You're doing maybe hundreds or thousands of invocations from a Lambda function to the RDS database constantly in the matter of few minutes, then you need to ensure that your database can support that. Maybe you don't want to set up a T2 database instance and then invoke thousands or 10,000s of Lambda invocations to your database, because probably that will slow down the entire process. So make sure that you choose the appropriate RDS instance, especially when you have a high concurrency with Lambda functions. There's also an architecture that you can use, which we call as kinesis sandwich. That means you are throttling the back end differently than the front end. So you have huge number of ingress traffic coming in, and then you have Lambda invocations happening. maybe the backend database is not really able to keep up with all the concurrency, what you can do is you can have a Lambda function and then put a Kinesis stream in between so that the Kinesis stream acts as a buffer layer before another Lambda function kicks in and goes and talks to the backend database. That way, you're introducing a buffer layer between your ingress traffic and back to your data tier. However, I think we all know that by adding additional layers in between, there's a chance that it can add additional latency. So keep that in mind when you are doing large number of invocations. Another good practice is instantiate database connections outside the function handler. So if you're aware of the Lambda function, right, when you write to a Lambda function, you start your initialization, and then you have your handler code that gets invoked and iteratively runs, right? So when you are actually creating the connection, which is essentially the database endpoint, username, password, and the connection string, and so on and so forth, try to do that outside your handler. That way, the connection is maintained for subsequent reuse. Especially if you are invoking the Lambda function multiple times in a matter of few minutes, few seconds, the connection pool or the database connection is maintained from the Lambda function to the backend database. That way, it does not have to actually go through the connection process every time. However, if you are running the Lambda function maybe every few hours, then you can't help it because it will have to create the connection every time. So make sure that you have the appropriate design practice when you are writing a Lambda function. There's various language libraries available that will enable you to maintain some connection pool. Just take a look at it, but I think just having a database connection outside the index handler should be really helpful. I think, meaning I already talked about that. Use RDS database definitely when you require faster query performance, especially RDS with Lambda works very well for complex querying, right? It definitely provides faster query performance, especially when it needs to talk to multiple tables for complex queries, joins, and things like that. Each database instance type also has a different max connection setting. So make sure that you're also ensuring that you set or fine-tune the max connections. The max connection for a T2 is different than max connection for a C4 instance. So when you are provisioning the database and you have concurrency with the Lambda, depending on the workload that you're running, make sure that you are fine-tuning that parameter as well. So the demo I'm showing here is you have a Lambda function that accesses or connects, reads and writes data to an Aurora backend database, which is inside your VPC. And in order to get your database username, password, credentials, I'm using KMS, which is a public endpoint, to be able to decrypt the password at runtime within the Lambda function so that you're not entering your username and password. You should never, in fact, hard code your username and password in a Lambda function, right? We also today announced environment variable support, so you can do some of those, but always ensure that don't try to hard code or maybe put your password credential in the Lambda function package in a clear text file, right? So I'm using KMS. So the encrypt option, that means the password file that you're encrypting is usually a one-time thing, right? Before you actually invoke, you encrypt the password file, package up the password file along with your Lambda function, upload that to Lambda function, and then the next time Lambda would needs to connect to the database, it simply goes, talks to the KMS, uses the keys to decrypt only, not encrypt, right? To decrypt, and then passes the password in memory back to the function so that the Lambda can talk, read, and write data to the database. So that's what I'm showing here today. So by doing this, what I'm showing the functionality here is the Lambda function is able to access both RDS resources, which is behind a VPC, which is the Lambda VPC configuration, and the NAT gateway configuration so that it can access, talk to the KMS public endpoint, which is outside the VPC. All right, let's go with it. So I have a simple Lambda function here, meaning I'm not a very core developer, so just forgive my syntactical thing here in the code, but it's a simple Python function that essentially has an RDS connection point, which is an Aurora database, and I have environment variable set for the username and name and things like that. And then I have a function running that essentially connects to the RDS database and maybe just writes some records and then reads some records from the database, right? It's a simple function, but I think you get the idea that the main demo functionality is to show how you can easily connect with RDS as well as KMS endpoints. And you have this function that essentially uses the KMS to decrypt the password at runtime, and then I'm using a regex expression to extract the password within the encrypted key file, and then passing that in memory back to the function so that it can go and read, write data to the RDS database. So that's the code here. Now let's go ahead and build that, meaning the function is built. Let's go ahead and ensure that so this is my laptop. So I have this package here, which is essentially the Lambda function package, and you can see this is the app Python code that I just showed you. Now first we need to package this and then upload to Lambda. So before, as I mentioned, before you upload, you need to encrypt the password key file. So I'll go ahead and so this is my clear text. I'm not going to show it, however. So this is my clear text, ASCII text password file. It can just be a password string or whatever, meaning however format that you're comfortable with, so that you can extract that password information within your Lambda function. So let's go ahead and in order to slightly accelerate the process, I'm just copying, pasting the KMS command. So use AWS KMS, encrypt, that's my KMS key. And then I'm using the plain text file to encrypt, and then I'm using the ciphertext block in base64 encoding. And then I'm generating a encrypted password file. There you go. So this command goes and talks to my KMS key file, generates the password in an encrypted. So if I do encrypted, so this is a encrypted file, right? Now we are going to copy this file to the Lambda directory. So there you go. Now this is our function. So we have the encrypted password file, we have the package, the MySQL in order to connect to the database. So we have everything here. Now let's go ahead and zip it up. I'm just copying. So it's now zipped. So we have an RDS lambda.zip. Everything is ready. Now let's go to the console. So I have the Lambda function here. So I already have the previous Lambda function. We are going to update that with the new package that we just created. So what I'm doing here is I'm going to use the zip file, upload a zip file, upload, and then use the zip that we just created and then save it. So now the Lambda function has the new package with the encrypted password file. We also have the CloudWatch logs open. I'll show you that, because when we invoke the Lambda function, it's going to send all the logging to CloudWatch so that we can compare and see all the execution that was performed in the Lambda, and we can also see the select statement through the CloudWatch. Okay? But before that, I also quickly want to show, in fact, hold on. So I want to show the VPC configuration for Lambda. So if you click on advanced settings, there you go. Here you are actually specifying the VPC where the RDS lives, so that the Lambda can create an ENI, attach to the VPC, and then talk to your database. And then you have your subnets, the VPC group, the security group, and everything mentioned there. I also want to show quickly the Aurora database that I have, that we are reading and writing into. So we have the Aurora database here, and you can see some details here. It lives in US West 2A. These are the subnet. And then I want to show one more thing, which is the NAT part. So if you go to the subnet and then say US West 2B, which is where our RDS lives, see the route table, and you can see anything outbound 0000, which is going out to the internet, will have to go through the NAT gateway instead of internet gateway. So keep in mind, as I mentioned, even if you specify internet gateway, your Lambda function cannot talk to the internet. You have to use a NAT gateway or a NAT instance within your VPC. Okay? So the Lambda function within the subnet now has access via the NAT gateway to the KMS. And then I showed you the database. So we are all good now. What we can do is, I'll also open CloudWatch. Now what we'll do is, we'll go ahead and invoke the Lambda function. So invoke the Lambda function. Let me clear the screen so that it's visible. I hope it's visible to all of you in the back. So I'm just invoking the Lambda function, and then I'm just redirecting the output to an output.txt so that we can see the output. So as you can see, the first time invocation of Lambda talking to an RDS, it has to go ahead and attach itself to the VPC, create the ENI, and then go and execute the SQL statements that we issued within the Lambda function. Keep in mind, it has to attach ENI, it has to go to KMS, public endpoint, decrypt the password, get it back, pass that to the function, and then read and write records to the RDS. So the first time is always a cold start. It will take X amount of seconds or milliseconds. As you can see, the status code is 200, which is successful. Now let's just quickly see the output. You can see some new records that have been added, but let us go ahead and look at the CloudWatch to make sure we can actually see the records. So you can see the time 1643, which was just invoked. And if you see the CloudWatch logs, it says success connection to RDS SQL instance succeeded, and you have all the records that we did a SQL select star. And then finally you can see at the bottom the duration, which is whatever 16.5 milliseconds. So if you issue the same command or issue the same execution SQL, now because the Lambda function and the container behind that is already started, it will just reuse the connection, as I said, without having to go back and do all the things. The ENI is in place, everything is in place. The next time, it will be much lesser. And Balaji will also demonstrate that in his code as well. So as we saw that using the VPC configuration, the NAT configuration, you have Lambda accessing both VPC resources and public endpoint. And not only public endpoint, it can go and talk to your resources within your on-premise data center, right? Because Lambda has access to internet. Yeah, it can go and talk to your connection within, if you have a VPN connection or a direct connect or whatnot, it can go and talk to some of your application resource on-premise as well. Now let's switch back to all right. So it's not hard, meaning once you have the initial configuration in place, it's pretty much an iterative process. So just make sure that you follow some of the best practices that I outlined there. Now we move on to ElastiCache. ElastiCache, people who maintain and manage databases, right? We all know that database performance is dependent on the back-end disk I/O and things like that. However, there are only certain things that you can optimize your database to improve performance, right? If you require very low latency in the order of microseconds when you're doing concurrent transaction at scale, meaning 1 or 2 transactions, that's fine. But keep in mind that you always need to plan for concurrency at scale, in which case it's always a good practice that you add a caching layer in front of your database, right? And that is the most common use case that we always know with caching. When you say caching, we always immediately get our mindset saying, hey, yeah, you can put a cache in front of your database, and that's it. However, ElastiCache, so ElastiCache supports both Memcached as well as Redis. So it supports both versions that you can configure based on your preference. However, in addition to just pure caching for improving read performance, there are various other use cases that our customers are using ElastiCache. One is Redis not only provides pure caching, but also acts as an in-memory data structure. That means it's a full data structure with lists, sorts, and a lot of things. So it's nothing but a NoSQL database, except that it is in memory. DynamoDB is a disk-based NoSQL. Redis ElastiCache is a NoSQL in memory. And you get fast performance and capabilities of a NoSQL database. So definitely a lot of use cases around that, especially around high-performance leaderboards, session management, where you need in the order of microsecond, millisecond latency because you don't have the time to wait and get back the response and whatnot, right? And you can also use that as an event counter, quick event counter. Redis supports increment counters, atomicity, right? Atomic counters. So you can, if you want to simply increment counter, decrement counter quickly, you can do that at very fast pace. So same thing, configuration and performance. Let's look at that. Configuration, since ElastiCache also lives within your VPC, you need to go through the same configuration that I just showed for RDS database. It's essentially a Lambda configuration for VPC. That's it. It's not like particular to RDS or EC2 or ElastiCache. As long as you enable the VPC configuration for your Lambda, it can access any of these resources, provided that it's in the appropriate subnet and whatnot. You can also simply use IAM roles to be able to manage access authentication to your Elastic resources. RDS, you require username, password for your database. IAM won't work, won't cut it for you there, right? So you require the additional configuration of username, password management, but here you don't have such complexity. And whenever you're writing Lambda functions for ElastiCache access, try to take advantage of some of the libraries that are provided. Node library, node discovery, PyMemcache that allow you to actually have the Lambda function discover the ElastiCache cluster nodes within your function so that it does not have to go and look for it, the nodes and things like that, especially in failure conditions. Simple, right? From a performance perspective, again, ElastiCache is meant to provide concurrency at scale because of the in-memory data structure and the in-memory caching layer. It is able to provide you with fast microsecond latency to your application at scale. However, you also need to ensure that you are using the appropriate instance type with ElastiCache as well, right? Although even a single ElastiCache instance node can support concurrency in the high order upper bound of millions of transactions, requests per second. But if you are doing that at very large scale, just ensure that you are selecting the appropriate ElastiCache instance for your Lambda function, especially with Lambda functions. It's quite important. Redis pipeline. So Redis is a TCP server. That means it's based on request response architecture, right? So you have a request sent to the Redis server, Redis responds back to the client. So you send 3 requests, Redis will process that one at a time, request response, which means it is kind of a serialized. That means it has to, for every request, it has to complete the response time, which will add the round trip latency for every request, right? While that is okay if you are doing single reads and writes or access, however, in Lambda functions, when you are doing batch updates to Redis strings, lists, counters, like hundreds of batch updates, right? Then, without using pipeline, you will have a latency issue. And then that can impact your Lambda function as well. Keep in mind, Lambda is a transient compute system that can run for 5 minutes and so on and so forth. So just always keep that in mind, right? So Redis pipeline is super helpful if you want to do real bulk updates to the Redis backend, so that the pipeline, what it will do is, it does not have to wait for each response or each request. That means if you are doing hundreds and thousands of updates, it does not have to send the response one by one. Rather, it queues everything in memory and then it just sends a response, or you can read that one time. So it drastically reduces the round trip latency between Lambda functions and ElastiCache Redis. Super helpful, right? However, given the memory constraints and whatnot, when you're doing batch bulk updates, keep in mind that you might want to batch it up maybe hundreds or thousands or 10,000 requests per second. If you have, say, million updates, you probably don't want to issue that at one set. So issue a batch of 100,000 and then the second 100,000, third 100,000 through a Lambda function. You can iteratively do that. Write through lazy load. So here again, you need to decide whether your application or your Lambda function can sustain read latency versus write latency. So when you're doing, so since ElastiCache or even Redis and Memcached is not a transparent caching layer. So when I say transparent, not transparent, I mean to say that unlike a traditional cache-based storage system, let's say it writes through and then the data is updated twice, you have to have your client application be able to handle that write to your ElastiCache as well as to the backend database. So your application has to be able to do that, right? So if you are doing lazy load, right, a request comes in, it looks up in the cache miss, goes back to the database, gets the request, and then your client application, the code that you have written, at that time should be able to add that record back to the Redis cache or ElastiCache. In which case, the round trip latency for writes will slightly increase, because one request to the cache layer at the first cache miss goes to the database, second trip, and then finally the application also has to write back to the cache because it sees that, okay, this needs to be in the cache. So 3 trips. So it adds the write latency. However, if you're doing write through, then you need to see the read latency, right? So usually people are, I'm saying applications are more tuned towards a little latency on the write side than on the read. you always want to get the reads faster, right? It's always by nature. When you want to run a query, you need to get the reads faster, but you are willing to make the compromise for writes a little bit longer, because you know that it always takes that additional bit of time when you're doing some writes as opposed to reads, because also it depends on the nature of your application, but generally applications are more sensitive to reads than to the writes. So make sure that you handle that within the ElastiCache, especially for Lambda functions. Memcached is ideally suited for read-heavy workloads. That means Memcached provides very high performance for caching, whereas Redis, because it's not only a caching layer, but it also is an in-memory data structure like a NoSQL database. Redis is more suited towards write-heavy workloads, because it can write using the data structures and whatnot. So depending on your application function, you can evaluate some of this. And I talked about that instead of updating the cache, right, you can easily just invalidate the cache, and then when you're actually, you have the client application write the data back, write the data to the caching layer. So you are not worried about the hotness of the cache or the data within the cache, but rather the client application is able to handle that additional latency, so that when it reads or writes, it can get it back from the cache layer.
Brilliant.
All right. So I'm going to now hand it back to Balaji for him to walk through a couple of demos that we have for ElastiCache with Lambda, and also some IoT with ElastiCache and Lambda as well. So those are cool demos, and take us through the rest of the presentation. Thank you.
Thanks, Prahlad. So we have 4 minutes left, so I'm going to try to do my best to cover some of these. So just to quickly summarize, we noticed how we were able to use fully managed service right from user creation all the way to your front HTTP endpoints, to your Lambda invocation, all the way to your data tier. If you're a web application developer or a mobile application developer, you know how important this is, that you don't have to manage your users, or you don't have to manage your function invocations. And with a single click of a button, you can increase the performance of your logic tier or your data tier to any range to support your application. So what I'm going to show right now is using ElastiCache and Lambda and API Gateway. I have a simple application that connects to the Memcached on the back end. And I have another demo using IoT devices, where I'm streaming a lot of devices that connects to the Redis on the back end. So in this example, what I have is an API gateway where customers are going to be connecting from what you see as client, and the integration request is going to be the one sending the request to my Lambda function for my logic tier. On the back end, it's going to connect to a Memcached database. So in my integration request, I have the Lambda function that is mapped. Once I deploy the API gateway and I have a URL that is available for me to access, this is what your customers or your clients will be accessing. This is my Lambda function. One of the best practices about, as Prahlad talked about in the talk, you want to be able to define your connection outside of your handler. So this enables your connection to be re-invoked, and you don't have, see, you're not closing the connection here, right? You don't have to, because Lambda on the container on the back end, it's smart enough to know there's a connection that is active. So I'm going to go ahead and reuse the connection. And let's say if you're downloading a file or anything like that in your container, it'll be available for you to access. So this is the function that I'm accessing and for my Lambda. And this is my ElastiCache node. And what I'm going to do, I'm going to access the production URL. You notice there's a bit of a delay. This is what we call a cold start. What it means is, as Prahlad highlighted in his talk as well, the container is trying to spin up on the back end. See, now we have now we have a value. So what's happening in the back end, because its Lambda function is invoked for the first time, I haven't invoked it before, to specifically display the cold start scenario. It's typical for common web applications for users to connect in the morning, and when evening and late night, the users will bleed out, and your Lambda function is not getting invoked. So you can get into a state where the first person connecting the next day morning can experience the same similar delay. So what can you do in the back end? you can have a CloudWatch alarm run at frequent intervals that can invoke your Lambda functions. So that way, it's always in a warm state. So what happens when I connect to this link for the second time? I'm going to open an incognito window and access this function. What happens when I access this subsequently? We don't see that delay anymore, right? That is really how you want to configure your application. So now I have a second demo. What I have here is using IoT. I have a simulator where I am publishing a lot of devices, simulating devices and the temperature and humidity and IP information into my AWS IoT service. AWS IoT service is a fully managed IoT service. It can support billions of devices and trillions of messages into the system. So I have a sensor hub that is set up. And here, this is where I'm accessing the Lambda function with that query information. I'm getting the query from all the temperature readings and invoking the Lambda functions on the back end. So this is my IoT MQTT client. All the MQTT messages I can see here in real time. And in my Lambda function, what I have, I'm connecting to the Redis data, and I'm adding some values based upon the temperature. If a temperature is in a certain value, I'm going to add a certain condition to that: hot, cold, warm, etc. So inside my configuration, we noticed different options that are available for memory and subnet and whatnot. And in the triggers, that is where my IoT is triggering the Lambda function. In the monitoring, we see Lambda was invoked about 14,000 times. As you could see, there's no servers involved. You are simply using compute, and my Lambda can really scale up to that much, and with 0 errors here. On the back end, in my ElastiCache, I do have a similar data point as well. My Redis cluster in the back, which is the ElastiCache, can also scale with the logic tier, which is my Lambda. What I also have is a simple web front end that can display all my front end, all the data from my temperature in a simple Elastic Beanstalk application. What you're noticing here, so I'm having a lot of data coming to my IoT service. In the previous demo, we saw using API Gateway. Here is IoT. Depending on whatever your front end may be, and you have your Lambda function that can scale with your application, and also your ElastiCache nodes, Memcached or your Redis, can scale in a fully managed way with a simple change of a parameter. You can automatically scale your application to whatever your application needs, right?
Go back to the.
Now we're going to go back to the presentation. We're going to look into some best practices around design configurations. So language runtime, the size of the functions and libraries will matter. For example, Python has a better startup latency. And we know that when Java Virtual Machine is already up and running, it provides a far faster warm option. We also notice the size of the function. When you're including the libraries on your Python imports or any of the supported languages, we support Node.js, and we released the support for C# as well, and also Java. Make sure when you're importing the libraries, you're importing only the specific modules. And it's very common practice across developers, including myself, where we import the libraries at some point, and the code changes over time, and then you're using some imports that are not currently active. So there are simple tools that is available to do some house cleaning and cleanup. You want to make sure you include that as part of your development process, because the size of the function and the libraries will impact the Lambda invocation. And larger memory size to improve the latency. So you can change there are about 23 different options that are available, more than 23 options that are available for Lambda memory size. Play with those numbers, see what is the appropriate configuration where you're getting the best performance for your application. If you have your own libraries, if you have libraries from different parts of your organization that you want to use, you can use as part of your Lambda library as well. There are no restrictions in terms of what you can do with Lambda. As long as you have a code that is executing, or a process that is executing within that 5-minute maximum timeline, or in any of the supporting languages, you can use Lambda.
Maybe you want to do the last slide
instead
of this. I think we are running out of time. We'll be posting all the slides online. So
retries, what if your Lambda function fails to invoke an action? So what happens when it comes to retrying or about the event order? How are you going to manage that? Let's say your function call is accessed synchronously. In that case, if you have an API gateway and you're calling a Lambda function, that is a synchronous invocation. So in that case, you want to leave it up to the client to control it entirely part of the SDK. Let's say your Lambda function is calling in an asynchronous manner. After 3 tries, the Lambda is going to discard the event. So in that case, you can let the function fail, and Lambda will drop the event in an SQS or SNS queue. This is a very exciting feature that we released a few hours ago, that was announced a few hours ago this morning. It's called dead letter queue, where you can let the function fail, and the Lambda will keep that in an SQS or SNS for a retry, or you can actually take some actions based upon that. So the Lambda can also pull a Kinesis stream or a DynamoDB update stream, where if you have a Kinesis stream, it's available for about a 24-hour period, so you can have the Lambda function to access the Kinesis stream and exhaust all the way until it's done. So in that case, the ordering is also preserved. Thank you so much for your time. We try to get as much as we can, so thank you so much.
You. So make sure you
fill evaluation. Please provide some feedback. It's going to be very helpful.
Thank you.